Hi, welcome back. So in this video, I'm going to go through an example of finding work, and this time it's an application problem. So since the words or the writing up of this problem is a bit long, I'm going to put it on the screen here and then I will read it out. So let's suppose you are going sledding with a toddler who needs to be pulled up the hill each time. So there's snow on the ground, you're sledding down a hill, and you have a little child with you and you're going to pull them up the hill. Then let's think that the force required to pull the sled up the hill is given by the following function. We have f of x is equal to 60 e to the negative 0.03 x. Here, x is the distance in meters from the bottom of the hill, so going up the hill, and f of x is measured in newtons, so it's a force and we're measuring it in newtons. So our task is going to be to find the work required to pull the toddler in the sled 25 meters up the hill. So, all right. When we do work, we are looking for an integral of the force, and here our force is dependent on the distance we are up the hill. So you can imagine maybe the hill gets flatter as we go up, so it's really steep at the beginning and then it flattens out. And so here, our force required is changing. It's going to be harder to pull the sled up the steep part of the hill, but it's going to get easier as we get to the flatter portion. What we do is we take the integral from a to b, where that's our interval we're looking at, and it's the integral of the force dx with respect to x. Just to do a little bit of work with the units so that we know what we're going to end up with, we were told that our force is in newtons, and our distance here is in meters, so our result is going to be newtons times meters, which is joules for work. So our final answer is going to be in joules. All right, then we just need to put in the other information. So we know that we're starting at the bottom of the hill and going up 25 meters. So I'm going to do that as 0 to 25. And then we put in our equation for force, 60e to the negative 0.03x. Now I really just need to integrate this. So truthfully, if you wanted, I would support you just putting this into an integral calculator, using whichever one you'd like, just to get a final answer. But this isn't too bad to integrate, so I'm going to go through the work, but just know that the setting up of this problem is sort of the new part in this concept, but it's always good to be able to do the integral too. So I'm going to do a little bit of a shortcut here. You could do a u substitution if you wanted to be more formal, but I know that I'm going to need to divide by that exponent, the constant. So I really have 60 times 1 over negative 0.03, and then I have e to the negative 0.03x. So this is because of chain rule when we take the derivative. The derivative of e to the something is e to the something times that derivative of the something. And so we need that 1 over negative 0.03 on the outside to cancel out. So this would come about if you did a u substitution as well, with u is equal to negative 0.03x. So feel free to do it like that if you'd like, but I like to kind of just jump ahead to the antiderivative since it makes sense to me to do that. Then my bounds are from 0 to 25, and I just need to substitute those in. Before I do that, I am going to simplify the constant. So 60 divided by negative 0.03 is negative 2,000, and so I have negative 2,000 e to the negative 0.03x from 0 to 25. So I substitute in 25, and then I subtract what happens when I substitute in 0. That's a minus 2,000, so we're going to have a plus 2,000 on that second term. I'm going through this a little quickly, just because at this point I'm hoping that doing the integral isn't too difficult for you, and it was more just seeing the connection with the application. That's the new part here. Now I just need to simplify. So negative 0.03 times 25 is negative 0.75. And then I'm just going to notice that that e to the 0 is going to be 1. So I have negative 2,000 e to the negative 0.75 plus 2,000 e to the 0. And when I compute that, I'm getting approximately 1,055.27 joules. And this is my work required to pull the sled up the hill, and it's my final answer. So there you go. Because we were given the formula for the force, all we really needed to do here was set up the integral properly to find the work and just make sure we keep track of the units to figure out what the units on our final answer are. Okay, that's it for this example. Thank you so much for watching, and I will talk to you in the next one.